grab your calculator as long as you're grabbing stuff.
Alright, I got the calculator. Hold up, I gotta print it out actually.
Okay. You say you gotta empty that?
No, I gotta print the book out.
Oh, okay.
Yeah.
Is it a website that I can go to on my end? Would that be an easier
yeah.
way of doing it?
I think, yeah, it is.
How would you like to do it? You want to verbalize the problems to me, or have me go to the website and we'll just do it?
Let me check it out real quick.
All right. I would need your password and user ID to log in probably, but.
What is the date, do you know?
The date?
Yeah.
February 22nd.
Alright, thank you. Page. Oh, here it is. Page 503. What the heck? Oh, it's not okay. Alright, February 22nd.
My brother's birthday today. Used to be George Washington's birthday when we were kids.
Oh, yes.
But they took it away.
Yeah, you can go to the website if you want.
Well, if you can verbalize them, we can do it the regular way.
Yeah, I can verbalize them.
Okay.
Let me just read it out so I can write it all down real quick.
Okay.
Why? What in the world? You don't do this. Yes, don't print it. Print. There it is. I got it.
Okay.
Alright, so the first one is the box and whisker plot, but you don't need to write the plot really.
Ooh, we doing statistics today?
Yeah.
Okay. Hold on, let me get my algebra book out. Go ahead and read the problem to me, and I'll see if I need to look up the statistics.
Actually, I should probably. I'll probably send you the link to the thing.
Okay. I've got my statistics book open here. I mean, not my statistics book, but the algebra book that talks about statistics.
Yeah.
That'll show me things like box and whisker plots and stuff like that. I don't generally do too much statistics tutoring, but I know the basic stuff.
Yeah.
It's odd. You get box and whisker plots when you're in Algebra 1, and then you don't tend to get them again.
Really?
Yeah, they, about the only people that ever give me box and whisker plots are Algebra 1 students. I never get it from an Algebra 2 student. In fact, it's not even in my Algebra 2 book. But I think I know. Yeah, no, they don't even have it in my Algebra 2 book. I got normal distribution and all of that, but box and whiskers is a little different. Yep, no, nothing about it. That's okay. Give me the problem. Maybe we can figure it out.
I just sent you the link to it.
Okay. Is it in the chat window? Or you sent it as an email? Okay. Let me pull up my emails. I didn't get it yet. You could also copy and paste it into that chat window, and I could just click on it immediately. You know, try doing it this time, because I didn't get that email.
Alright, so
if you go down to the chat window, and you see where you're supposed to type, enter your message, copy and paste it into that, and then hit the enter key, and it'll go into the chat window. And then I can just click on it directly at the chat window.
Is that on the computer?
On the GoToMeeting control panel,
Yeah.
see where it says chat?
Yeah.
Okay, you might have to open that up. Yeah, there you go. Now I can click on that link.
Oh, that was the wrong one. That's my mom's company thing.
Okay.
Alright, send it.
Tell me when it's in there, because I'm looking at a bunch of text. I'm not sure what. Is it in there? Oh, there it is. Okay. Now you should see it on my screen. All right, cool. All right, let's have a look at this. I'm sure we can figure this out. And you know how to minimize your GoToMeeting panel?
Yeah.
So that it doesn't take up a lot of space?
Yeah.
What's the first question here?
It's just top left is the one I'm on right now.
Okay. What percent of the numbers are located between 5 and 14? What percent of the data is either less than 5 or greater than 9?
Between 5 and 14 is 8. No, wait, that's not right. Hold on, let me see this.
Box and whiskers. Is this the quartiles?
Yeah.
Is that the second quartile?
Between. Wait, what are you asking me?
Well, I'm not sure what the answer is, to be honest. Do you know how to do this one?
Yeah.
Okay, good. Tell me.
So there's 0.83% located between 5 and 14.
83%?
Yeah.
And you got that how?
Calculating.
9 divided by 14? What? How'd you calculate it?
Yeah, it's like 10 divided by 12.
10 divided by 12. Why do you do that?
12 divided by 10.
Why do you do that?
I don't know, but that's
let's go on. As long as you know what you're doing on that first problem, I guess it doesn't matter if I do. I think I can figure out most of the others. So the upper right, who's the most consistent golfer and who's the best golfer? Well, who's the best golfer? The best golfer is the one that's got the lowest mean, right? In other words, Connor averages 83. The other three guys average 85, 85, 87. Well, the best score in golf is the lowest score. So Connor's the best. MAD means what?
I do not know.
I don't know what it is either.
Yeah, I don't know.
It would seem MAD. I'm tempted to say that David is probably the most consistent golfer because he has an 85 mean and his MAD is lower than the other Alan is.
Yeah.
So I suspect MAD has to do with consistency. I don't know what it means, but...
Yeah, you're probably right.
All right. Let's go down to the next problem on the left.
All right.
All right. This one we can do. Now let me move it over. Let me make a table. Hold on. This is fairly straightforward.
Yeah.
You've got handed around on the top. You've got left and right. And you have female and male, like that. So of 68 males, 63 of them were right-handed. So I can put 63 right there, right?
Yeah.
Only 12 of the 109 people surveyed. Well, let's add another column here and put total.
Okay.
How many females must there be? There were 68 males, right?
Yeah.
And 109 total people, so how many females must there be?
41.
How many left-handed males must there be?
Hold on, let me get all this down. 5.
Now, only 12 of 109 people were left-handed. How much has to go in the left-handed female? 7. That gives us a total. And a lot of times it's good to put a total on the bottom also. In other words, make another row for total because I know that total is 12. Now I can fill in this square. How many female right-handed are there?
Hold on. I know this. Don't tell me. I can do this.
Remember, these two columns have to total to the column on the right. There's 41 total females, right?
34 females, right?
34 right-handed females. And now we got everything we need.
Yeah.
Okay, in other words, this has to be 109. And if we needed it, we would know that there are 97 right-handed players, 12 left-handed players, 68 males, 41 females.
Yeah.
So you can always complete these tables. But sometimes it's very helpful to add another column and another row at the bottom and the right that gives you your totals, because that's very helpful in figuring out how to figure out some of the inner boxes.
Yeah.
Okay. Now let's look at the next one. Johnny determines a line of best fit. Okay.
Okay.
It's actually a pretty easy one. So he determines that if he were to put this into two lists and ask the calculator to come up with a line of best fit using linear regression, it comes up with this. How would I figure out the y value? What y value would you predict to correspond with an x value of 14?
What? 14?
What y, based on this equation,
Yeah.
what y value would you predict to correspond with an x value of 14? How are you going to solve that answer?
I do not know.
Well, what y value would equal an x value of 1? Plug in the answer lies in plug in the x value and see what you get for y.
Yeah.
So all you got to do is plug in 14 for x.
Yeah.
So the y is going to be 42 times 14 minus 55. What number is that?
42, hold on. I want that calculator real quick. 42 times 14 minus 55. Yeah, 533.
Now, does that make sense based on the table we're looking at? X is going up by 1s, y is going up by 30s. So yeah, if I went up to an x value of 14, I would expect to be in the neighborhood of 533.
Yeah.
So it's very believable. Now, there's some question right below there that's covered up. How about, what's the rest of it say?
I don't know, but I think she covered it up, so we didn't have to solve it.
Okay. All right, so let's go to the next one.
Yeah.
You understand this line of least fit?
Yeah.
In other words, if you have a table like this and you just have points, then you just have a series of dots. You don't really have a function. You have a series of dots like this. In other words, if I were to graph the x and y values, this is what I would get. And the line of least fit is the best line you can draw through those points. In other words, that line I drew through those points looks to me like that's the best line I could draw through them. It's certainly better than this line, right?
Yeah.
Well, your calculator uses an algorithm to come up with the perfect line, given a bunch of dots. So the very first part of that problem says that your calculator told you that y equals 42x minus 55 is the equation of my black line. That's what it's saying. Once I know the equation of that, then I can use it to predict any y value given an x value.
Okay.
Now, this next one. So they give us a bunch of dots, and then they give us 4 possible equations. Well, let's start with, what's the y-intercept going to be of the best line I could draw through those dots? Straight line. Where's it going to be approximately?
What's it going to be a fraction of?
Where's it going to be approximately? In other words, connect these dots with a straight line. Where does it cross the y-axis?
Do I need some kind of fancy calculator for that?
No, just draw a straight line. Or look at it. Put a straight line through those 7 dots, 8 dots. Where does it cross the y-axis?
I'd say 12.
7, right?
Yeah.
Well, it's not 5. It's not 2. So
Yeah.
the bottom 2 equations are out. So it's between the top 2 equations. Both of the top 2 equations have a y-intercept of 7. Which one has the proper slope? What's the slope of that straight line? Is it positive or negative?
Negative.
That makes this answer correct. Y equals -1/2 x plus 7.
Alright.
And I don't think this was a calculator problem. I think this was intended to just kind of draw the best line you can put those dots together with and then approximate which equation is that where you what you came up with.
Yeah.
All right. The next one.
Yeah.
We're converting to a relative frequency table.
Yeah.
Well, the relative frequency table that's down below it, the upper left-hand square of that goes with red and male, you want that to be a percentage number.
Yeah.
There are 12 red males out of a total of 50 people. So what's that frequency? 12 divided by 50.
Let's see. Would that be 4.16?
No. 12 divided by 50 is the same as 24 divided by 100, which means it's 24%. So you can either put 0.24 or 24% in that box.
Okay.
At least I think this is the way they want you to do it. The next box that goes with green and male, well, there's 7 of those out of 50 people. That decimal is 0.14. Do the same to these 8 boxes, and these 8 boxes below will total the number 1.
Yeah.
However, there is another possible way they want you to do this, and that is this upper left box where it says 12, they may want you to divide that by 28 males so that all the numbers going across total 1. I don't know. Do you know? Again, statistics is not my strong suit.
I could ask her tomorrow and I can go in either way.
What's that?
We have this thing called the ICE where it's like you finish all your work, so I could do that tomorrow.
Okay. It's a very simple problem. The question is, are you going to divide each number by the total or by the number of males? If you divide each one by the total number of males, then your top row, the first 4 blocks, are going to add up to 1. If you divide it by 50, the total number of people, then your top 4 and the next 4 on the second row are going to add up to 1.
Yeah.
So I'm not sure which they want. Relative frequency tables, I understand the concept, but I don't know that they want you to break it down into male and female or just total. I would say just total.
Yeah.
I would think. And then you'll notice, in other words, here, can you see where I'm pointing?
Yeah.
Okay, so if that number is 0.24, this number is 0.14, this number is 0.18, and this number is 0. Add those up and you'll get the total relative frequency of all the males. Well, there's 28 males. 28 divided by 50, well, what will go in your total box here? And then do the same thing to the females, and that total box will give you a number, and then those two totals will add to 1. That may be the way they want you to do it.
Yeah.
It's one way or the other. I know that. All right. Let's go down. These are weird. They're not numbered.
Yeah.
How about after that middle problem here?
No, I finished all of the ones except for the bottom page. I haven't finished those ones yet.
The factor completely, the bottom row?
No, the bottom, just like the bottom page.
Oh, okay. Well, let's go there then.
Alright.
So we've got, hold on. So we got 3m plus 10m. And they want to know what km over 2l is. Well, they tell us what k, l, and m are. So first of all, what's 3m plus 10m?
It's 13m.
Okay, and m is minus 3, so what's their sum? If it's 13m, which is correct, now substitute minus 3 for m, and what do you get?
No, it doesn't correct.
Minus 39. 13 times minus 3 is minus 39. Okay? Now, km over 2l, that's pretty easy. They're telling us what k is. They're telling us what m is. And they're telling us what L is. So simplify that. What do you get?
You get...
Make sure you simplify that the easy way, not the hard way. Don't do 21 over 6. It's not the way to do it. The way to do it is to cancel that 3 with that 3. Now you get minus 7 over 2, and that's the answer. You see how I did that?
Yeah.
You see why that's superior?
Yeah.
In other words, I never dealt with a number greater than 7. Whereas if you just do the straight multiplication, top and bottom, you got to deal with a number as big as 21. And then you got to figure out how to reduce 21 over 6. So simplifying before multiplying is something you always want to do. Okay, the next one, 8r minus 10s, and s to the t minus r. All right, again, they give us r, t, and s. So what's 8r minus 10s?
8r minus 10 is, we can't really simplify that.
Well, by simplifying it, I mean plug in the values you know for r, t, and s. And then simplify the number. So 8 times r is 8 times 11. minus 10 times s. Well, s is 9. Now that you can simplify.
Yeah.
What is that?
That would be, I know this.
Okay.
90.
Okay. It's 88 minus 90.
Yeah.
What is 88 minus 90?
That is -2.
Okay. Now do the same thing for the bottom. In other words, the first step on these, just to plug in what they've given you. So
Yeah.
plug it in for me.
11 minus 9.
No, we did that one already. Now the second part of that is s to the t power minus r. Well, plug in for s, t, and r, and we'll figure out what we got. Tell me, substitute for those 3 letters. Tell me how to write it.
S to the power of t.
No, plug in for s, t, and r. See at the top of that panel, they tell you what s, t, and r is.
Yeah, 9 to the power of 3.
Okay, that's what I'm looking for.
Yeah.
Minus what?
11.
Okay. Now simplify that number. You might need your calculator to do 9 to the power of 3.
718.
Okay, there you go. All right, let's look at some of these factoring problems. This is where we should have started because these are classic algebra problems.
Yeah.
Okay, what's the very first thing I should think of when I go to factor something?
Get the x by itself.
No, greatest common factor. Always think greatest common factor.
Yes.
Is there a greatest common factor?
Yes, there is.
What is it?
3.
Okay, so I'm going to factor out the 3. What's left behind?
Negative x squared.
Hold on. Let's go left to right. There's a reason. So what's 75 divided by 3?
That would be 25.
Okay. Minus what?
X squared.
Okay. Now, you recognize that? What's that called? What's the second way to factor? Basically 3 factoring techniques. There's greatest common factor. After you get done with that, then look for difference of perfect squares. If you have difference of perfect squares, do that. If you can't do either of those first 2, well then the next thing is to factor it as a quadratic.
Yeah.
Okay, well, is this difference of perfect squares?
Yes.
Yeah, 25 is a perfect square number, x squared is a perfect square number, and they're being subtracted. So it is the difference. In other words, if I put a plus sign there, it no longer is the difference, and I couldn't factor it. But as long as they're being subtracted, I can use difference of perfect squares. How does that factor as difference of perfect squares?
30 parentheses 5 minus x.
Good.
That would be 5 plus x or 5 minus x again?
No, it's always the conjugate. In fact, once you get the first term, you're done with the math. You don't need to do any more math. Just always make that term the conjugate. Okay, and then that's fully factored. All right, let's look at another one here. This one, could they make it seem any harder?
No.
What the heck are they doing? Did I write that right? All right. What's the, hold on. That's all right. Wasn't sure what dropped the call. Okay, so what's the first technique to consider?
Factoring.
Greatest common factor. In other words, this is a hellacious looking, that's not even a quadratic, that's to the 10th power. I'm not even going to be able to begin this unless I can take out something.
Okay.
Well, what's the greatest common factor that I can remove? What's the greatest number?
5x.
No, 5 doesn't go into 8, doesn't go into 24. I got to find a number that divides into all three of these numbers, the greatest one possible. Okay, 4. That's the greatest number that comes out. What's the greatest variable that can come out?
X squared.
X squared. Okay. Now, tell me what's left over.
We have a
Go from left to right.
5x.
Hold on. Go from left to right, which means the first term is going to be 8x squared divided by 4x squared. What's that? That's just 2.
Oh, sorry about that, yeah.
Now keep going. Now what's the middle term?
4x squared.
No. 5x. 4 goes into 25 times. 5x cubed. And then the last term?
And 6x to the power of 8.
Why would they give you a problem like this?
I do not know.
I don't either. I've been tutoring a long time. I've never seen a problem like this with Algebra 2 and Algebra 3 students. So what the heck is going on? Maybe that's as far as they want you to go.
Maybe.
That's probably the answer. When they say factor completely, that's as complete as we know how to factor. And here's the thing that you probably don't realize yet. Any quadratic, let's take a quadratic like this.
Okay.
I can factor all quadratics. Even if I have to use the quadratic formula, I can do it. Quadratic formula just gives me, as long as I know what A, B, and C are, I plug it in, I come up with the 2 answers. So I know how to factor quadratics. But believe it or not, the moment you turn it into a cubic, something like this, that is a half-an-hour problem.
Yeah.
And you won't learn that until you take precalculus. When you start getting into higher degree polynomials. This is what I've circled here at the bottom is not a quadratic, it's a cubic. And cubics and quartics are unbelievably difficult to factor. There is no such thing as a cubic formula like there is a quadratic formula. Okay? So I know they don't expect you to know how to factor these bigger polynomials. And boy, that's an 8th degree polynomial. So I don't think they're expecting you to try to factor that down. I wouldn't know where to begin if they did. So I'm guessing that that's their final answer.
Okay.
Yeah, let's keep going here. Let's make sure you get the gist of what they're trying to teach you here. And that's mainly make sure you recognize and start every problem by greatest common factor, and then check and see if you have difference of perfect squares, and then check and see if you have a normal looking quadratic. Like we're about to get to normal looking quadratics. The next few are normal looking quadratics. We'll be able to factor those. This one does not have a constant. Okay? If it doesn't have a constant, then at a very minimum, I'm going to be able to take a D out. Greatest common factor. Is that all I can take out? Is there any number I can take out? No, there isn't. 11 is prime, and if 11 is prime, then it doesn't divide by anything except 11, and 15 doesn't divide by 11. So I'm going to take a D out. What am I left with?
You're left with 11D and negative 15.
And there's your answer. For sure on this one, that's the answer. Now, I'm glad we got a little bit of time left to do some of these normal-looking quadratics, because this is the skill you need. This is the most important skill you will get out of algebra.
Yeah.
Okay? And I would like you to do it the way I've taught you. What's the first step? Split up the K's.
Exactly. You get K on each side.
What's the second step?
Minus each.
Nope. Wouldn't be able to produce a minus 48 if they were both minuses. Always remember that you've got to be able to produce that number when you multiply these two things back together again. Well, the only way you're getting a negative sign is if the signs are opposite.
Yeah.
So I know one's got to be plus and one's got to be minus.
Yeah.
Okay, that's step 2. Now, what's step 3? Verbalize it out loud.
Yeah. Would it be factoring the
Factors of 48 that do what? Not add. Notice what's in front of the 48, a negative sign. So they got to subtract to the number 2. Well, what are factors of 48 that subtract to 2? Well, let's do it the hard way. What's the next? Give me another set of factors. What's my second set? In other words, you need to know how to factor a number.
Yeah.
Okay, so what's the second set of factors? Always try cutting this one in half and doubling the other. So 24 and 2 is a set of factors. 12 and 4. Keep going.
And then 6. Yeah, 6 and 6.
6 and 8. If I'm going to cut one in half, I got to double the other.
So it'd be 6 and 8.
Okay. Which one goes with the negative sign?
The 8.
Right. The bigger factor goes with the sign on the middle term. The sign on the middle term is minus, therefore the 8 has to go with the minus. And the 6 goes there. All right? Let's keep doing these. I'm going to jump to this one, and then we'll go back to the previous one. I'm still convinced that if you got, so you could do these 100% properly, you'd have a huge skill. Whether you could do the previous problem or not that's got a 3 in front of it, wouldn't matter. If you could do all first level quadratics properly, that's gigantic. So give me the steps.
We're going to divide the x's.
Separate the x's. Second step?
We're going to keep the find the greatest common factor. Find the number to add.
Now hold on. Notice that whenever you have a quadratic, a true quadratic, where you have a constant, there's never a greatest common factor. I can't take an x out. So I can never do greatest common factor on these. Not as long as the coefficient on x squared is 1. which it is. So I've got to split the x's up. Second step. Everybody forgets the second step. The second step is to determine both signs. What do both signs have to be? Has to be plus plus. I could produce a plus 40 if it was minus minus. So it's either minus minus or plus plus, and I know it's plus plus because the sign on the middle term is plus.
Yeah.
Now, verbalize step 3.
Find the numbers that add to 14 and multiply 40.
Okay. Add to 14 and multiply to 40. What numbers are those?
10 and 4.
And this time it doesn't matter which one goes where. In other words, as long as these two signs are the same, then you can put the numbers, there's only 3 steps. It's not a 4-step problem.
Yeah.
All right. Now let's go back and look at one that's slightly harder. You and I haven't talked a lot about these because there's not 3 simple steps like when we're dealing with a simple quadratic.
Yeah.
First step's still the same. I got to split up the k's. How do I do it? It's only one way to split them up.
Well, do you need 3?
Well, they got to multiply back together to give 3k squared. So how do you split it up so that they would multiply back to give you that? Just like that.
Pretty simple, okay.
Yeah, it's very simple. Especially when they can only factor in one way. If that was 4k squared, then I could have 4k and k, but I could also have 2k and 2k.
Yeah.
But 3 only factors one way, 3 times 1. Okay? Now, what are both signs?
They're both plus.
They're both the same because that plus sign in front of the 14. But being the same doesn't mean they're plus plus. They could also be minus minus. You look to the sign of the middle term to tell you which. Well, it's negative, therefore they have to both be minus minus.
Yeah.
Okay? Now, the next step is a lot of trial and error.
Yeah.
If I look at, I need factors of 14 and there's not very many. That's it. Okay? Well, always try. It's a trial and error process, so always try the 2 factors that are closest together. Okay? So I could put a 7 there and a 2 there. Does that produce that as a middle term? And here's where you got to throw out all those other rules. In other words, I cannot say factors of 14 that add to the number 13. No longer true. I do need factors of 14, but that's about all I can say. And I'm just going to try various combinations. Now, to see if this combination works, check what your middle 2 terms are. Well, you get the middle 2 terms from the inside and the outside. Well, that's minus 2k. This is minus 21k. That gives me minus 23k. That's not what I'm looking at. I'm looking at a minus 13k, so I don't have it right. Well, there's only one other possibility, and that's to put the 7 there and the 2 there. And now, do the check. The check is an integral part in solving these because it's the only way I really know whether my answer is correct or not, is by doing this, what I call the double smiley face check. Well, that's minus 7k, the insides. The outsides are minus 6k. Add them together, you get minus 13k, bingo. But I had to do this double smiley face technique in order to figure out where to put these 7 and 2. And if that didn't work, then I'm going to go try 14 and 1. Okay? So these are what I would call at least secondary quadratics in degree of difficulty. Because it takes, in other words, when you have elementary quadratics, there's either 3 or 4 steps. And you could write it down and you'd do every single one of them exactly with those 3 or 4 steps and it would be foolproof.
Yeah.
But when you get these where there is some coefficient in front of the squared term that's not 1, well then it kind of throws all those rules out the door. You'll notice that's not the only one on this page, but let's keep going. We've got 6 minutes here. So we've done that row. Let's take a look at this one. This is elementary again, right? And I know it's elementary because it's a 1 in front of the x squared.
Yeah.
Okay, so go through every step, one at a time.
Alright, well we split our x's. So x on each side. And then our signs are going to be plus minus.
Hold on. Plus minus would give you a minus right there.
Oh,
So it's what?
What is plus?
No?
No, it didn't. Minus.
There you go. Minus minus. In other words, the plus in front of the 45 tells you both signs have to be the same. That's all it tells you.
Yeah.
It tells you specifically it's not plus minus. It's either minus minus or plus plus.
Yeah.
Well, look to the sign on the middle term, tells you it is minus minus. Now you got all those nice easy rules. What are you looking for? Fact. Start by saying factors of that do what?
Factors of 45 that add 14.
Okay, perfect. That's always the way I'd like you to think about it. When I say verbalize it out loud, I do that for a reason. Because I want you to think about that third step. It's always factors of the constant that either add or subtract to this number.
Yeah.
Okay, well, what factors of 45 add to 14?
10 and 5.
Let's go through the process.
Oh, no,
Let's go through it because this is a hard one to do. Can I cut 45 in half?
Oh, 9 and 5.
Ah, well, let's still go through this process. I cannot cut 45 in half, right?
Right.
Can I cut it in thirds?
No.
Yes. 3 goes into that 15. So it becomes 15, and I got to triple that. Well, I can't cut 15 in half, but I can cut 15 into thirds. Becomes 5, and I got to multiply this by 3. That becomes 9. There's my 2 factors I'm looking for. And again, it does not matter which one goes where, since both signs are the same. Okay. Let's see. Let's do... Can you do this one quickly in your head? The one on the n squared minus 17n? What's the third step going to be? Factors of what? That do what? Factors of 72 that add to 17, is that what you said?
Yes.
Okay, what are those factors?
Would be 9. No, it would not be 9.
Yep.
It would be.
Well, you can always do it the hard way. The one thing your calculator can never do for you is factor a number. Okay, so the hard way is to do it. Can I cut that in half? Yes. Can I cut it in half again? Yes. Can I cut it in half again? Yes. There I have my 2 factors that add to the number 17.
Yeah.
And so my answer is going to be n minus 9 times n minus 8. So some of these you get to a point where you can do them pretty quick. But it's still important to realize you're just doing those same 3 steps.
Okay.
And it's that simple. Okay?
Alright.
Now, we got time for one more. Let's do this one.
Alrighty.
Let's do it step by step.
Alright.
I'll do the first step for you. Second step.
Maybe to figure out our signs.
Correct. That's always the second step. Figure out both signs, not one at a time, both signs.
Maybe minus plus.
Or plus minus. Notice that it doesn't matter whether I write plus minus or minus plus.
Yeah.
Third step, verbalize it.
Factors of 20 that add to negative n.
Not add.
Subtract to negative
Subtract and not to n, to the coefficient of n. What's the coefficient of n?
We do not know.
1.
Why don't we know?
We do know. It's 1.
We do?
Yeah, whenever you don't have a number in front of a variable, it's always 1. The coefficient of n squared is 1. The coefficient of n is 1. Well, technically negative 1. But our rule merely says factors of 20 that subtract to the number 1. This coefficient without sign. That's 5 and 4, right?
Righto.
Where's the 5 go?
On the right.
And the 4 goes on the left. So just because that middle term doesn't have a number on it doesn't mean there's not one there. That's why I wanted to do this problem. It's because a lot of people do exactly what you did, which they say factors of 20 that subtract to n. Well, it's not n, it's the coefficient of n. And it's not even minus 1. It's 1. Whatever this number is, that's what you want your factors to subtract to. And then you just have to figure out which one goes with the minus, which one goes with the plus.
Yeah.
All right.
Alrighty.
Nick, I will talk to you next Wednesday.
That's good.
All right. Bye-bye.